Sequences is what we're going to be working on now. Sequences are a set of numbers in a row, usually following a mathematical pattern, such as the Fibonacci sequence. The Fibonacci sequence starts out with 1 and 1 as its first numbers, and then all other numbers after that are made by adding the previous two. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 would be 21, and so on. We get to 34 and 55, and on it goes. You can see how this would go on forever. This would be an infinite sequence because it does go on forever. If we had put a close or an end point on it, then it would be a finite sequence. An example for us to use, let's take a look at this problem. So let's say we've got a sub n. So first of all, let me tell you, a sub n is the nth term. Or in other words, this is the general term. And that's how you can find a specific number. So the general term equation for this particular problem that we're going to come up with is going to look like this. Let's say a sub n equals 4 times n plus 2 to the nth power. And what we're going to do is we're going to solve for the first 4 numbers, a sub 1, a sub 2, a sub 3, and a sub 4. We're going to solve for these first 4 numbers. So for the first one here, we're going to take 4 times n, and n being the first number is going to be 1 plus 2 to the first power. And when we simplify that, we get 4 plus 2, which actually ends up equaling 6. So there's our first one. So we continue that pattern. 4 times 2 plus 2 squared, 4 times 3 plus 2 to the third, and 4 times 4 plus 2 to the fourth. So what do we get? Well, 4 times 2 is 8, 2 squared is 4, 4 plus 8 is 12, and then 4 times 3 is 12, 2 to the third is 8, 12 plus 8 is 20, and then 4 times 4 is 16, plus 2 to the fourth power is 16, and we end up with 32. So that's how we find each of the values or the nth term from a sequence. So what we're going to do now is we're going to go ahead and take a look at what we call a recursion formula. So let's go ahead and shrink this up. Notice that this one, we were able to find the nth term by knowing what n is, and that is our general term. Okay? So in this next example, what we're going to find is that we're going to figure it out based on, oops, take that color back. We're going to figure it out based on the previous number. And so that's going to be called a, oops, let me change color. That's going to be called a recursion formula. Recursion formula. Why is that? Because it keeps recurring from the last number. Recursion formula. So let's start out with this. So let's say our first term, or a sub 1, is a 3. And every other number after that, a sub n, is going to equal to 2 times a sub n minus 1. Minus 1. Now what's going on here for real? Well, this part here, this a sub n minus 1, that's the previous term. If a sub n is a number, then a sub n minus 1 would be the number before that. So let's do the same thing here. Let's find the first 4 numbers. We already have a sub 1, so we're going to find a sub 2, a sub 3, and a sub 4. So a sub 2 is going to be based on this answer. So we're going to have 2 times the previous answer, which is that one, 3 minus 1. And 2 times 3 is 6, minus 1 is 5. So now we're going to use the 5 in the next one. So we're going to do 2 times 5 minus 1. 2 times 5 is 10, minus 1 is 9. Now we use the 9 in the next one. 2 times 9, because it's the previous number, right? 2 times 9 minus 1. 2 times 9 is 18, minus 1 gives us 17. So there you have it, folks. We are talking about recursion formulas and general terms for sequences and the Fibonacci sequence. Next thing we're going to talk about in a few moments in the next video is going to have to do with factorial notation and summation notation. Here it comes.